working with sampling distributions, either in part 6 or part 7, we are using the normal distribution to find probabilities. So we're still going to do that the exact same way we did back in whatever the heck, in part 5 when we talked about the normal distribution. So we're still going to go to the calculators and normal. The only difference is that we're going to have to read our question stem ahead of time to figure out what mean and standard deviation to use. So if we're talking about a proportion, we're going to use a mean of the real p, right? And our standard deviation is the square root of pq over n. And if we're talking about a sample mean, we're going to use the mean of the real mean and the standard deviation of the real standard deviation divided by the square root of n. So I just wanted to point out we can still use our normal distribution. Let me show you an example from the lecture notes. So if we look at exercise 1 here, we can actually see first some keywords that let us know we're even doing something with the normal distribution. We see the question here asks us to find a probability. So if we're looking to find a probability, it's usually a good indication that we're doing something with our normal distribution. As I said, that's really the key of all the stuff we learned before. So I'm going to go ahead and snip this so that I can underline some stuff. Bloop. Cool. I will bring it over so we can be looking at the same thing. All right, and I'm going to be writing with my mouse, so bear with me as this is going to be hideous. But we're looking for the probability of 43% or more out of these 200. So first thing I notice here is that we're given a cutoff, right? We know we're looking for the probability of 0.43 or more, so greater than or equal to. And 43% is a percentage, right? It's a proportion, and it's from this sample of 200 students. So we're talking about this probability that our p hat is greater than 0.43. So this is when we go to our notes and we'd recognize, oh, right, it says the mean of p hat is the real p. Somewhere they must have given us real p. Well, up here they said in 2001, 89% of those surveyed. That doesn't seem like a real p. It seems like a survey from a super outdated study. And then we say, the next sentence says, assume this is true. All right, fine. So we can assume this is the real deal, 0.39. I already have my mean. My standard deviation is going to be the square root of that. I cannot write. Times its q, which is 0.61. We already did this question, but the point is, that's all we need in order to tackle this thing in StatCrunch. We're able to say, okay, well, we know this is 0.39. I hope I didn't just change that. Yes. My standard deviation, well, let me go quickly throw that into a calculator. That's the one limitation of StatCrunch. It does not do basic calculations for me, so I have to do them. It looks like that was 0.0345. That gives me 4 decimals. That's good. And we wanted to see that it was greater than or equal to again, I've already forgotten, 0.43. So we've got all the pieces, we can press compute, and we've got our drawing, and we're done. So that's how you can use a normal calculator. If we're in 7.1, same exact business, use the real mean as your mean, and then calculate your standard deviation doing that square root of n as your denominator.